Hi, welcome to Math with Mac. Today I will be going over common questions that I get as an undergraduate tutor regarding derivatives for beginner level calculus. This includes basic calculus for business majors, this includes calculus for engineering, and calculus 1, and this includes also calculus infused with pre-algebra. So let's start by just the very basic. What is a derivative? So we know a derivative as something you might have heard as a rate of change. Now, what does that mean? Think of it like this. Let's say I have a car, right? I know I'm not necessarily an artist. And I move from spot A to spot B. This is a change in my position. All I've done is driven from A to B. For example, I've driven from Knoxville to Nashville, right? But in real life, we don't just teleport from A to B, right? There is some kind of rate of change of I'm going from not moving at all to moving to again not moving at all because I start at rest and I end at rest, right? Because I get in my car, I'm not going anywhere. I drive to my destination and I stop when I get there. We call this change here from stop to start a form of a rate of change or a derivative. Now, this shouldn't be confused with acceleration because acceleration is actually the second derivative. So let's say in a more mathematical look. So let's say I don't know, the rate that the function position, position of my function of my position, oh my, is x squared plus 3x plus 4. And this gives me, I don't know, blank amount of feet that I've went at any given time, right? Well, and this is f of x. Let's call it f for space. Well, then when I take the derivative of this, which we will go over how to in a few minutes, I get 2x plus 3, and I drop 4. This will give me some amount of feet per second, which is my speed or my velocity. Technically, speed and velocity are slightly different, but for our purposes, no, they are not. And then let's say I do it again. Now I get some kind of answer that is going to be feet squared per second. And that's my acceleration. So don't get that confused in my initial explanation. But when you're thinking of what a derivative actually is, think of it as driving a car. It's your speed from getting to point A to point B, or your velocity point A to point B. So let's start and don't let me scare you. Let's start by looking at something that looks super, super complicated, okay? So let's look at f of x equals, let's do sine of x squared plus 3 times x cubed all over 2x, or let's make it 2 cosine of 5x. We have no idea what we're working with here. You can't just take this derivative in your head. But we can use tools that we have to be able to do this. So let's start by acknowledging that we have to have division here, right? So we know we're going to be using our quotient rule, which we will go over pretty soon. Just stay with me. And then up here, you can see that we have sine of x multiplied by x cubed, which will give us product rule. And then we can see we have something going on here inside of those trig functions. So that's a pretty good hint that we're going to have chain rule in this problem. And then we also see that this is just x cubed, right? That's really hard to read. We have x cubed, right? So we know we can use the power rule as well. So let's talk about what those things are and then come back and attack this problem at the end. So our power rule. All this is saying is that if you have something simple like x to some exponent that is not another variable, all you have to do is subtract it by 1 and multiply it. So some examples of this might be if f of x equals x squared, f prime of x equals 2x. Or if f of x equals 3x to the third, our f prime, or our derivative, is 3 times 3, x to the second, because I did 3 minus 1, which equals 9x squared. Now, something that is very important to note here, what this does not mean, if I have, and I'll do it in red to remind you this is not true. If I have f of x equals x to the 2x, I cannot use power rule here. So this is not simply power rule. This is going to be a chain rule, but we'll come back to that. Now, product rule, this one is the multiplication one. So all this is saying is if you have one function multiplied by another function, you take the derivative of one plus the derivative of the other, and you multiply by the one that you didn't use. So if you've ever played the game Snake, where you've got the box and you've got your little snake, and you can only go in one of the 4 cardinal directions. No diagonals are allowed. You have the same issue in math, is that you can't just go straight to it. So like if I have h of x, and I'm just using h because I like f and g. You don't have to use f and g. It just makes sense to me. But if you have h of x equals, I'm going to do 3x sine of x. So I have 2 functions here, right? I have 3x and I have sine of x. So my first function, 3x, and my derivative of that is 3. Well, then I have my second function, which, let's do it in pink. G of x is sine of x. Then the derivative of this is cosine of x, right? So because you can only change one thing at a time, you can't go diagonal. You have to account for both. So the first part of this, which let's do it in light blue. This function right here is saying that if only the x and f of x were changing, then the derivative would be 3, because that's my derivative of my f of x function, times just what was the g of x base, right? Then we add a linear relationship. You may have heard that term. But it's not just that f of x changing, right? G of x is also having a derivative and also having a rate of change. So we take this to account for what we didn't account for in the first one. So we keep our 3x because we've already taken the derivative of that function. We don't want to do it again. And we multiply by the derivative of the second function. And that should be your final answer for a product rule question. So then our quotient rule. This is always going to be division. So this looks big and scary, but it doesn't have to. So again, we just have 2 functions, f of x and g of x. It's the same as on this one, where they can be anything. So let's take these 2 f of x's and this f of x and this g of x, and let's apply them here. So let's say instead I gave you h of x equals, what was it, 3 of x and 3x over sine of x. And remember again that we can't just take a derivative, right? Of both, at least. So we have to break them up in some way. So we've already identified from the last problem that f of x is 3x, f prime of x is 3, g of x is sine of x, and g prime of x is cosine of x. Well, from here, we kind of just plug and chug it, right? So we get our f prime 3 times just the plane g of x, right? Sine of x. But now we're subtracting because it's division instead of multiplication, right? But otherwise, it's the same as before, right? But that's not quite enough for our division. So we have to remember to divide by the original bottom function squared, which in our case was sine of x, right? So we squared. So that is also all that the quotient rule is. It looks scary, as does the product rule, but it's not too bad. Now, chain rule is the one that everyone tends to struggle on, the most at least. So I've written out what the mathematical function for it is, but I want you to take your mind off of that and follow me for a moment. So let's use an example here. And let's make a new piece of paper. So let's say I have f of x, or let's use h again, sorry. H of x is equal to sine of 3x. Now, I don't know about you, but I have it memorized that the derivative of sine of x is cosine of x. And I know that the derivative of 3x is 3, but I don't necessarily know how sine of 3x is going to react. But what I can do, and what is the essence of chain rule, is I can say h of k, make that a little bit easier to read, h of k equals sine of k. If and only if k equals to 3x. So now I know that if h of k, whew, k equals sine of k, well, now this is just another base derivative that I know that I have memorized, right? So my derivative of h of k is just cosine of k. No different than the x, right? But over here, I know, let's change color real quick. Let's do blue. K must equal 3x for this to be true. Now my derivative of k is 3, right? So now I take my derivative that I just got and I plug my k back in, okay? So I do h prime of k, or of x, equals cosine that I got from here, and I plug back in my k. That's not enough, right? Because that's no different than having to just use my memorization and plug it back in. And it doesn't change that much, right? So now I have to multiply it by the k. So a good way to see this as well is to look on Desktop's, the calculator app. So let me make sure that my screen is sharing. So let's say we had f of x being, what was it, sine of x? Sine of 3x. As opposed to sine of x. You may notice that the amplitude, so the distance from the axis, stays the same, but the period is different, right? Which the period is how many, I guess, squiggles pass. So if I just take the derivative of cosine of x, and let's hide this really quickly, you would agree this is the rate of change of the sine function, right? But it is not of 3x. So I've used 3x, but that's still not quite right? It's still just a bit too much. So I have to multiply it by 3. And that's how I get my rate of change. And you'll notice that that makes more sense, right? Because these are happening so much quicker than just with the base function. So now to go back to our notes. We've now done kind of a high overview of each of the basic derivatives. So let's go over and try applying some of them. And now would be a good time as I write them to pause, try it on your own, and come back and see if you took the same approach that I took. So let's start with h of x equals 2x to the fourth. Now let's make it a little tricky. Let's add plus 3x. So now is a good time to pause if you want to and try it on your own. But to continue, one of the first things that I remember that I know I haven't mentioned in this video, but hopefully you've learned in your class, is that linearity, so that plus sign and that minus sign, means that I can cut it right down the middle, right? Because this is the same as saying f of x equals 2x to the fourth. F prime of x is 4 times 2, which should be 8, x to the third. And over here, we make it blue so that it's a little bit easier to see. G of x is 3x. G prime of x is 3. So now, because it's linear, we can say that h prime is the same as f prime plus g prime, which means for us that our answer is 8x to the third plus 3. So now, something that you may be asking yourself is, why do I keep writing that f of x? Why am I not just writing f and g? And here's why. So let's say I give you f of x equals 3xa. But I tell you up front that a is a constant. Well, that means I don't want to take the derivative of a, because a could be any number. It just represents something, right? A could be 4, a could be 4,000. It doesn't really matter. So the way that we would want to treat this is like the power rule, right? Where we have 3a x a minus 1. But now if we're not told that, if we're told that the a should be included, we know that we're going to have to use implicit differentiation. And we're not going to touch on that in this video. I'll make a different one. So let's try another. And don't be afraid to stack them too. So like, let's look at this one. H of x equals cosine of x to the 17 multiplied by 3x squared. If you want to pause now, that's fine. But to continue. So this is a multiplication, so it's a product rule, right? So just to remind us, the product rule, p prime of x, and I'm just going to call it p for product, is f of x, g of x, plus f of x, f of x prime times g of x, plus f of x times g prime of x. So now our f of x is cosine x to the 17th. But remember, this is a problem, right? Because we don't know that. But we do know that f of k is cosine of k, where k equals x to the 17. So f prime of k is negative sine of k, and then k prime is 17x to the 16, right? So that means that we can deduce that f of x prime, using chain rule, will be 17x with 16 negative sine of x to the 17, right? And then g of x, let's draw a little line. Hold on. Okay. So let's scoot all this up a little bit. There we go. So now g prime, g of x is 3x squared. G prime of x is 6x, right? So now, of course, show your work every time that you do this, but just to make room for the point of following through on this problem, I'm going to erase my chain rule work. And that's just to make sure that you guys can see what I'm doing as I do it. If I were writing on paper or doing this for myself, I would just get out a new piece of paper. So now all we have to do is plug into the product rule and say that h of x is equal to negative 17 x to the 16th sine of x to the 17th times 3x squared. And I'm out of room, so I'm going to write my plus sign down here. And then multiply that by cosine of x to the 17 times 6x. And that's my final answer. So, let's try another one. Let's try h of x equals 3x squared over, well, no, let's make it 6x squared over 2x. If you would like to pause the word here, feel free. So this is actually a trick question, right? Because the first thing you're probably seeing is that there's a division, so we're probably going to use the chain or the quotient rule, correct? But what happens here and here? If you have x squared over x, that is just x, right? And 6 over 2 is just 3. So all this actually is h of x equals 3x. Well, that's just the power rule, right? So h prime of x is just 3. But for a separate one, let's try h of x is sine of x over cosine of x. Or no, let's make it x squared. Because I think sine of x over cosine of x makes tan of x or something, tangent. But so we see the division and we can't simplify it. So now we know that we have to use our quotient rule. So we have our f of x is sine of x. And our derivative of that is cosine of x, right? Well, then our g of x is x squared. And our g prime of x is 2x, right? So then all we have to do is plug and chug, right? Because it was h prime of x is I'm just going to take it with me so that we're writing it. There we go. So it's f prime first. One way that I remember this is I tend to do top and bottom instead of f and x or f and g when I'm doing this. And I remember that the t comes first because it's second in the alphabet. And t is just for top. You can also remember this as f as being the first to take the derivative of because f comes first in the alphabet. Completely up to you. But I digress. So our final answer will be cosine of x times x squared minus sine of x 2x all over x squared, which secretly is also x to the fourth. And that is our final answer. So now let's go back and get that big one, right? The one that looked so scary when we first started. Let's erase some of this writing on it. Hopefully it doesn't look so scary this time around, right? You see the pieces. So let's start by noticing that we have quotient, right? So let's go ahead and label, move this up a little bit to our top. So on top, we have product root, right? Which we also have product on the bottom, one side at a time. So we have f of x on the top is sine x squared plus 3. G of x is x to the third. G prime of x is 3x squared. So over here we have the chain rule again, right? So we know, let's switch it to green, that f of k is sine of k. K equals x squared plus 3. So f prime of k is cosine k. K prime is 2x. Because remember, constants don't have a variable to change, so they get kicked out, right? So now we know that our derivative of f of x using chain rule is 2x cosine of x squared plus 3, right? So that's our top. So now let's look at the bottom. And let's look just at the bottom. We have that same issue, right? So we have f of x equals cosine of 5x if and so now we can set up so that f of k equals cosine of x, or k, sorry, k equals 5x. So the derivative of f of k is negative sine of k, and the derivative of k is 5. So now we know that the derivative of f of x is negative 5 sine of 5x. So you may notice I didn't include that too, because I don't have to, right? Because it doesn't have a variable, so it's just a scalar. And by scalar, I just mean that it multiplies it, right? So now I know that my actual bottom derivative, so let's call it that, is 2 times negative 5, which is negative 10 sine of 5x. So now let's go break all this down. So, okay. So now we have the top which let's erase some of this. Let's close. Sorry, that's supposed to be parentheses. And we have the derivative of the top. We found over here. Oh, we forgot to multiply it, didn't we? Because now we have to do 2x cosine of x squared plus 3 times x cubed plus 3x squared times sine of x squared plus 3. But now we can copy all this over. Make it a little bit smaller so it fits. And then on bottom, we had 2 cosine of 5x. And on bottom prime, we ended up with negative 10x, or negative 10 sine of 5x. And now remember, our quotient is f prime g minus fg prime over g squared, which means that we have all of this multiplied by all of this, which let's just go ahead and fill in parentheses and then paste it. And let's go ahead and erase this and scoot it over so we have more room. And now we have to subtract all of that by the other one, right? So we have, I'm just gonna be able to fit it all, sorry. So we'll subtract it here and do sine x squared plus 3 x cubed. Don't forget your parentheses when you multiply by g prime, which is negative 10 sine of 5x. And I'm adding parentheses here to make it more clear. And then all of that is divided by 2 cosine of 5x squared. See, it really wasn't all that different from all the little ones, right? It's just one big one put together, all the little ones put together. So when you're doing your derivatives, remember to invoke your simple rules for better outcomes. And make sure that when you're using them, you're not afraid to stack them. Just because there are a few, like just because there are ones that look complicated, doesn't mean that it's not, like you can have product and chain rule at the same time. Just make sure that you keep yourself organized. I really like to do the columns where I split f of x and g of x and work down them. But it's all in what makes the most sense to your brain. So hopefully that has helped. And if it doesn't, feel free to reach out to me. Thank you. Have a good evening. Bye.